Welcome back to the Dargslan Linux series. This is part 6, and today we're stepping into the living, breathing side of your system. Every command you've run so far, every browser tab, every background service, they're all processes. In this part, we'll learn how to see what's running, understand why it's running, and take control when you need to. Here's the path we'll take together. We'll start with what a process actually is. PIDs, parents, and children. Then meet PS for quick snapshots, and top and htop for a live view of your system. From there, we'll get into killing and signals, learn how to juggle foreground and background jobs from your shell, and finish with the basics of CPU and memory. What numbers like load average really mean. So let's start with the foundation. A program is just a file sitting on your disk. But the moment you run it, the kernel loads it into memory and it becomes a process, and every process gets 3 things you'll see again and again. A PID, its unique ID number that tools like kill and top use to refer to it. A PPID, pointing back to whatever process started it. And yes, your shell is the parent of every command you type. And a user, the owner whose permissions that process runs with, which ties straight back to the file permissions we covered in part 4. And that PPID idea scales up into something beautiful. Every process on a Linux system traces its ancestry back to a single root. That's PID1, usually systemed on modern distros. The very first thing the kernel starts at boot, and the eventual parent of SSHD, your bash shell, Nginx, cron, and everything else. To actually see this family tree on your own machine, just run pstree. Add the P flag, and it'll print each PID alongside the name, so you can follow the chain with your own eyes. Now, pstree gives you the shape of things, but when you want details, CPU usage, memory, who owns what, you reach for PS. Think of it as a snapshot, a single frozen picture of every process at the moment you hit enter. The classic incantation is PES-OS, which lists everything on the system in BSD style. You'll also see PSEF, which is the same idea in System V formatting, and PSIU followed by a username when you only care about one user's processes. Pipe any of them into grep, and you've got a quick way to find exactly what you're looking for. But a snapshot only gets you so far. When you want to watch your system breathe in real time, top is the tool. It refreshes every few seconds, showing uptime, load average, how your CPU is being spent, and where your memory is going. And once it's running, a handful of single-key shortcuts make it surprisingly powerful. Press M to sort by memory, P for CPU, T for time. U to filter down to one user, K to kill a process right from the interface, and Q when you're done. It's basically a task manager built into every Linux system you'll ever touch. Now, top does the job, but htop does it with style. It paints your CPU and memory as colored bars, lets you click column headers to sort, hit F5 for a gorgeous tree view of parent and child processes, and even use the mouse if you want. A quick apt install htop is genuinely one of the best small upgrades you can make to a Linux system. Tiny investment, pay off every single day. Once you've spotted a process, you might want to talk to it, and that's what kill does. Despite the dramatic name, it just sends a small signal. Signal 15, SIGTERM, is the polite default. Please wrap up. Signal 9, SIGKILL, is the nuclear option. Instant termination, no cleanup, only when 15 doesn't work. And Signal 1, SIGHUP, is the gentle one most people forget. Perfect for telling a daemon to reload its config without restarting it. So here's the actual workflow in practice. First, find your process. pgrep with the A flag shows you matching processes and their PIDs. Then send SIGTERM by just calling kill with the PID. Give it a few seconds to clean up. If it's still hanging around, escalate to kill, 9. And if you'd rather skip the PID lookup entirely, pkill matches by name. Just be careful with common names, because pkill bash on a busy server is a story you don't want to tell. Now, killing processes is one way to manage them, but often you just want to keep your shell free while something runs. That's where jobs come in. Stick an ampersand at the end of any command and it runs in the background. Your prompt comes right back. If something's already running and tying up your terminal, hit Ctrl+Z to pause it, then BG to let it continue in the background, or FG to pull it back to the front. And jobs on its own lists everything you've started in this shell, each with a little number you can refer to, like FG%1 to grab job 1. Beyond individual processes, you'll often want a quick health check on the whole machine. And 3 little commands cover most of it. Free H shows your memory situation. The column to watch is available, because that's what new programs can actually grab, not the smaller free number. Uptime gives you load averages over the last 1, 5, and 15 minutes. And as a rough rule, if that number climbs above your CPU count, the system's working harder than it can keep up with. And DFH lists free space per file system, which is worth glancing at regularly, because a disk that hits 100% will take things down with it. Since load average trips so many people up, it's worth slowing down on. Those 3 numbers are snapshots over 1, 5, and 15 minutes. So you can see what's happening right now, what just happened, and where the trend is heading. The key is to compare them against your CPU count, which you can check with nproc. On a 4-core machine, a load of 4.0 means you're fully booked. 8.0 means there's twice as much work queued up as your CPUs can actually handle. So let's put all of this together into a quick troubleshooting playbook. When the system feels sluggish and the fans are roaring, open htop and press P to sort by CPU. Find the culprit and decide whether to kill it or live with it. If apps are crashing or browser tabs keep reloading, run free. H, a low available number means you've run out of RAM. If your load average is way above your core count, pair uptime with nproc to confirm, then hunt the heavy processes in htop. And when you hit no space left on device, DFH shows which file system is full, and DUH, max depth 1, lets you drill down to find what's eating the space. Now, before you go off managing processes in the wild, let me warn you about 3 mistakes that bite almost everyone. First, don't reach for kill 9 right away. SIGKILL gives the process 0 chance to save its work or close files cleanly, and databases can actually corrupt from this. Send a plain kill first, wait 5 or 10 seconds, and only escalate if it's truly stuck. Second, be careful with killall and pattern matches. Running pgrep, a Apache, first lets you see exactly what you're about to take down. And third, remember that closing your terminal usually kills the jobs you started in it. So for anything long-running, wrap it in NoHup, or better yet, run it inside screen or tmuck so it survives your session. So let's pull it all together. A process is just a running program, identified by its PID and tied back to a parent and a user. Use PS when you want a snapshot or something to grep through, and top or top when you need to watch the system breathe in real time. Remember that kill sends signals. Start polite with SIGTERM. Save the nuclear option for when nothing else works. Background your long jobs with an ampersand or Ctrl+Z so your shell stays free. And keep free H, uptime, and DFH in your back pocket. Those 3 answer most of the questions you'll ever have about a machine's health. And that wraps up part 6. Next time, we'll move into package management. How Linux actually installs, updates, and removes software using tools like apt, DNF, and pacman, depending on your distribution. You're a quarter of the way through the series now, so take a breather. Maybe try killing a few processes of your own, and I'll see you in part 7.